Hello students, today we will be learning another important feature of the object-oriented programming, that is inheritance. Now we know in object-oriented programming we can create classes and then later on we can create instances of those classes. Instead of writing the classes from the scratch, is it possible that we can create the classes from the existing classes? That is, we can use their code in forming the new classes. That is, we can use the code of the existing classes in forming the new classes. This is somewhat like inheritance in the life sciences, where a son or a child can inherit the genes of a parent, okay, or in real life where the son inherits the property of a parent. Something like that happens here also. We have already a class called the base class, and that class is used to create a new class called a derived class. The derived class inherits the features of the base class and adds some new features of its own. The technique of building the new classes, that is what we call as derived classes from the existing classes, that is what we call as base classes, is called inheritance. The derived class inherits the features, that is function and data members of the base class. This is what is meant by features, that the since the class has only two things, that is the data members and functions, and any class has these two members only, these two types of members only. So these features will be inherited by the what we call as derived class from the base class. That is, the derived class will inherit function and data members of the base class, okay, and then it can add its own functions and data members. Then the programmer can add data members and function members to the derived class, but some property will be inherited from the base class. There are certain rules for that. We will be seeing those rules, that what are the functions and data members that are inherited by the derived class. But for in the simple sense, you can understand in the preliminary stage that the derived class obtains or inherits certain function and data members from the base class, okay. Now next, the syntax for the derived class is, normally whenever we create a class, we write the class keyword, then we write the name of a class followed by two curly braces, and in the end we keep a terminator. I have not written a terminator here, there's a terminator, we've seen that, and then within the class we declare the members of that class. Now same syntax is used here, thing more added to the first line. What is the thing that is added is mode of the inheritance or visibility mode, and the base class name from which the derived class is inheriting. So in addition to the normal class, what you call syntax, we have got two more additional things. One is the mode of the inheritance and then the base class. In fact, the derived class can be created from multiple base classes. So it is not that a what you call a derived class will inherit from a single base class, it can inherit from the multiple base classes. In that case, the first two things, that is the mode of inheritance or visibility mode and the base class name, will be repeated for as many base classes from which a derived class is inheriting, okay. Now there can be three modes of inheritance. That is, for this step, that is the mode of inheritance or visibility mode, for this option we can have three possibilities for the mode of inheritance or the visibility mode. These are public, private and protected. This is different from the access specifier, even though the keywords that are used for the mode of inheritance or visibility mode are same, that is their spelling is same, but for the mode of inheritance or the visibility mode, public, private and protected have a special significance in case of inheritance, in addition to the access specifiers which we use in the derived class. Now if we don't specify the mode of inheritance or visibility mode for the inheritance, then in that case private is the default mode. So to sum up, now the derived class will have the syntax, that is in class name then derived class name. This is the normal syntax up to this stage. Now after that we have a semicolon, and after the semicolon you are going to specify the mode of inheritance or visibility mode of a class. For this we have three values, that is public, private and protected, and this mode of inheritance or visibility mode is optional. If you don't specify it, we have a private mode of inheritance, and then we give the base class name from which the derived class is inheriting the function and data members. Okay, then after that we have got two curly braces, and within these two curly braces we will be writing the code of the derived class, that is its function and data members, whatever are there. So this is the addition, that is the mode of inheritance and the base class name. Okay, now there are certain rules we have to keep in mind once we go ahead with the inheritance. The most important thing rules are given here. First, you should remember that private members of the base class are not inherited in the inheritance. Okay, only public and protected members are inherited. So private members of the base class are not inherited, only public and protected members are inherited. In addition to this, since constructors and destructors of the base class are declared in the public section, but they are not inherited by the derived class, even though public members of the base class are inherited, but the constructor and destructor of the base class is not inherited by the derived class. So the first important thing we should remember, I am stressing on this point, that private members of the base class are not inherited at all. Okay, only protected and public members are inherited, but among the public members of the base class, the constructors and destructors of the base class are not inherited. Now, rules for the mode of inheritance apply to public and protected members only. Okay, now once we are inheriting, we have to specify the mode of inheritance. As I told you, there are three modes of inheriting, that is public, private and protected. So a derived class can inherit the function and data members from the base class by specifying the mode of inheritance. And for the mode of inheritance, we can have public mode of inheritance, private mode of inheritance or protected mode of inheritance. This mode of inheritance is different from the access specifiers which we are giving inside the class. And if we don't specify the mode of inheritance, then the default mode of inheritance will be private. But the mode of inheritance is either public or private or the protected. So once the derived class inherits the code and what you call data from the base class, that is the function and data members from the base class, we have to specify, the programmer has to specify the mode in which it is inheriting. As I told you, there are three modes and there are rules for these three modes of inheritance. For private mode of inheritance, that is if the derived class is inheriting from the base class in private mode, then the public and protected members of the base class become the private members of the derived class. Okay, this is important. As I told you, the private members of the base class are not inherited, So these mode of inheritances will put their effect on public and protected members only, because only these members are inherited. This is important. So once a derived class inherits from the base class in the private mode of inheritance, that is, it is inheriting privately, then in that case the public and protected members of the base class will become the private members of the derived class. Okay, and if the mode of inheritance is public, then in that case the public and the protected members that will be inherited by the derived class will continue to remain as public and protected members of the derived class. Okay, I hope this is clear. That is, in case in public mode of inheritance there is no change to the public and protected members. Once they are inherited by the derived class, they continue to remain as the public and the protected members of the derived class. Okay, now in protected mode of inheritance, what happens? The public and the protected members of the base class that are inherited will become protected members of the derived class. So whatever is the mode of inheritance, it will put its effect accordingly on the public and protected members of the base class and will change its access specifier in the derived class. There is only one mode of inheritance that does not change the access specifiers of the members, that is public and protected members, that is the public mode of inheritance. But in private mode of inheritance, once the public and the protected members are inherited by the derived class, they will become the private members, okay, of the derived class. In protected mode, the public and the protected members, once they are inherited, their access specifiers will change to the protected. Okay, but in case of public there won't be any change. As I told you, private members are not inherited, so they are not accessible. Okay, once we will discuss the accessibility of a members who have already done some exercise so far as the access specifiers are concerned. But once we inherit from a base class and we create a derived class, we'll see what are the rules for that. Okay, this will be clear once we go into IDE. Okay, now there are certain forms of inheritance. These are the forms of inheritance, not the modes of inheritance. In single inheritance, the derived class inherits from a single base class. In multiple inheritance, the derived class inherits from the multiple base classes and then adds features of its own. But in single inheritance, the derived class inherits from a single base class and adds features of its own. By features, I mean its own function and data members. Now in hierarchical inheritance, it is like a tree structure where there is a parent-child relationship. Multiple children can inherit from a single parent. Okay, that is, the multiple derived class will inherit from a single base class. And then if we move to the next level, then the derived classes can become the base classes for new derived classes, and same process will continue. There is not the limitation that suppose we have a single base class, any number of classes can inherit from it. Okay, It's not that only one class will inherit from that class. Okay, so we can have a class A, it can be inherited by class B, C and D. Okay, it can be there. Or we can have a class B, it can inherit from multiple base classes. Say we have base classes L, M and N, and we have a class B. The class B can inherit from L, M and N. It's not that a class can inherit from the single base class, or a what you call class can inherit from a single base class, it can inherit from the multiple classes. Or if a class inherits a particular class, it cannot be inherited by other classes. That is not the case. So based on that only we have single inheritance, multiple inheritance, hierarchical inheritance, multi-level inheritance, hybrid inheritance and multi-path inheritance. As I told you, in single inheritance, there is a rule that there got to be a single derived class and it inherits from a single base class. In multiple inheritance, there are multiple base classes and a what we call derived class inherits from all those base classes. So it inherits the properties of multiple classes, but only their public and protected members. As I told you, private members are not inherited. Now in hierarchical inheritance, we have got a parent and its property can be inherited by multiple children. Then these children can become the parent class or base class or the next level. Okay, and the next level classes, that is these derived classes, can inherit the properties of their parents. It's like a tree structure, it's a hierarchical structure. Now in multiple inheritance, we have got a single class that is inherited by a derived class. Then this derived class can form a base of some other class, and that class can inherit the property of this derived class. Now the derived class that has been created becomes a base class for that class. So that is a multi-level inheritance. In hybrid inheritance, there is no order. Okay, there is no order of the inheritance. I'll be showing in these forms of the inheritance one by one. We will be discussing these and in the ID, but I'll have to break this video into multiple videos, and since there is a lot of content that needs to be covered, it cannot be covered in a single video. Okay, in multi-path inheritance, there can be a derived class which inherits the base class of some higher level from two different paths. Okay, this I'll show you diagrammatically. No need to worry about it. In today's exercise we'll be handling single inheritance, in which we have got a single base class and a single derived class, and the derived class will be inheriting the property of a base class. Okay, now default constructors of the base class and derived class are invoked directly. That is, the constructors without the arguments are invoked directly when the derived class object is instantiated. When we'll be instantiating the derived class object, the default constructors of the derived class and the base class will be invoked automatically. If the base class contains a parameterized constructor, then we have to call that explicitly. This we have seen earlier also, that parameterized constructors are to be called explicitly. How we call them? Then again I have to show that in the ID. No need to worry about this. Constructors are invoked in the order of class hierarchy. So the constructor of the base class will be invoked first, then the constructor of the derived class will be invoked. And if there are multiple levels of the inheritance, if it forms a what we call hierarchical tree, then we will see that the classes that are in the top of the inheritance tree, or whatever are the base classes, top level classes, their constructors will be invoked first. Okay, then the derived classes, constructors, so on and so forth. In case of multiple inheritance, the single class can be inherited from multiple base classes. So in that case, the order of the execution of the constructors is the order in which the inheritance has taken place. This again we will see in the ID. Destructors are invoked in the reverse order. Okay. So if we have a base class and a derived class, in case of constructors, in case of single inheritance, the base class constructor will be invoked first and then derived class. But again, the destructors, they will be invoked in the reverse order. That is, the destructor of a derived class will be invoked before the destructor of a base class. Okay. We'll see that again in the ID, and this is again a vast topic, and we have to see it for the different forms of the inheritance. Okay, how the constructors and destructors are involved. But the general rule is that the order of the constructors in the order of the class hierarchy, but in case of destructors, they are invoked in the reverse order, that is reverse hierarchical order. Okay. Now, overloaded member functions. We can have a function in the what you call base class and in a derived class with the same name, even with the same number of arguments, and even with the same return time. So they won't be actually overloaded in the sense they will have a different number of arguments, or they will have different return time. The two functions will be exactly the same, and it is possible that we have two functions. So it is not in the strict sense, it is not overloading of a member function, but that is also possible that we can have two functions with the same name, and then they can differ either in type of arguments or number of arguments or order of the argument. But there can be case when the two function definitions are exactly the same, and in that case we will see that once we create the object of a derived class, it will refer to its own function, in which even if we have the function with the same name defined in the base class, and suppose if that function is inherited in the derived class, still the function of the what you call the derived class is invoked once we use the object of a derived class. We are going to see today prelims of the inheritance, and I'll be uploading some more videos on this topic. But in this prelims, if you understand it, it will be very easy to follow. Okay, so in inheritance, it's a technique in which we create new classes from the existing classes. The new classes are called as what we call derived classes, and the existing classes are called as base classes. There is no specific rule that a derived class can be created from a single base class, or a single base class can be inherited by a single derived class. It is possible that a single base class can be inherited by multiple classes, and it is also possible that a single derived class can be created from multiple classes based on a particular order in which a derived class and a base class can be used in the inheritance. We have different forms of inheritance, and today we are going to study single inheritance. In single inheritance, we have a single base class and a single derived class. This is the simplest form of the inheritance, and we will be studying that way. But if you understand it, it will be easy for you to follow other things. Let us go into ID. Let me create a class first called base class base. Okay, now I declare some members in it, both data and function members. I'll have all the three parts in this so that we can understand the accessibility of different members and their inheritance part, and we'll have a private part also. Okay, now in public part I declare the integer, say a public, and for base I'll be a public base and a public. Okay, now then I create a function public, say base. Okay, or b function public. Okay, and then it is just simply to show you what is the accessibility of different functions and data members of a class. Okay, I'll be keeping these functions as empty functions, just simply to explain you accessibility, and later on we will do programs, we'll implement some concepts and we can go for some examples to explain all these concepts. Okay, now I have got another, but that will be instead of public PA, I will call it as PA protected, and then I can call P function protected. Okay, so I have got a public part and protected part. I have got both data and a function member in each part. Now I have both parts in BA private and then B function instead of public private. Okay, now we have created a class, example class, called as a base class, which will be inherited by the derived class. Okay, now let me first explain the accessibility rules, which I have already clarified in the previous videos, but for general understanding it is very important that I revise it, and we can go for inheritance after this. Now we know that this base class has data members and function members. It has got 3 data members and 3 function members. We have a data member from each category, that is from public category, protected category and private category, as well as we have a function member from each category. Okay, now these functions, the members of a class, are called as a member functions of a class. Now we have got member functions as B function pub, B function pro and B function pri. These are the 3 member functions of a class. I have not written anything in their body. They have a null body because I am going to explain the access specifiers here on. So far as the functions of a particular class are concerned, you see they can access any member of a class, and that too without a dot operator. Suppose I am accessing bfunpub. In bfunpub I am accessing bapub and initializing it to 10. Similarly, I can access ba pro, I can initialize it to 11. Okay, then I can initialize access ba pri. Okay, ba pri equal to 12. The moment I compile, let us see. Okay, this error is because I have written a terminator there. I should have written colon there. Okay, not because of the access problem. Let us compile it again, and if you see, there are no errors. So accessibility is not a problem so far as the member functions are concerned. They can access the public part. This is the public part, since this has been declared in the public section, and this is the protected part, and this is the what you called private part of a class. So for member functions, you should remember that there are no access rules. They can access any data members that belong to them. Okay, now since this is a public function, let us try to do the same thing in the data in a function member which is private. Okay, and protected. Okay, let us try in private, and let us try to access all the members in protected function. And once I compile, you'll see there won't be any errors. So this is a clear-cut indication that a function can access any other data member, that is whether it's public, private or protected. That's a member function. Now so far as class base is concerned, it has got 3 member functions, and I have tried to access the 3 data members in them. Now let us try to access other functions in them, so that we'll see whether we can access them. Accessing a function is calling a function or invoking a function. Let us call the function b fun pro init. You will see there won't be any error. Okay, there is no error. And let us call b function private init. There won't be any error again. Okay, and because compiler reports the access violations, it is a compiler that reports the access violations. You will see again. I'll try to call these functions in function protected function also. Okay, instead of function protected, I'll be calling function public here. Okay, and in private function also I'll be calling the other 2 member functions. So I'll be calling the public function here and protected and public function here. Okay, that is the other 2 functions, and you will see there won't be any errors. Okay, no, there is no error. Okay, so there is no access violation so far as the member functions are concerned. They can call any other member function, and the member function of a class can call any other member function or can access any other data whether it is a public data or private data or protected data that belongs to that class. Okay, so access specifier rules don't belong to member functions. Then where are they applied? They are applied in the non-member functions. Now what are the non-member functions? All the other functions that are not the part of class are taken as non-member functions, whether those functions are belonging to any class or those functions are belonging to other classes, because there can be functions in C++ that don't belong to any class. Those functions are particularly those functions which are not defined in the body of any class and are not bound to any class. Okay, and we can have member functions of other class, but they are non-member function for classes other than that. Suppose we have a class called base class. We have a 3 member functions here. All the other classes, their member functions will be non-member functions for base class. So this is a respective term, that now if I have another class, a class A, and it will have its member and data functions. Now all the other classes member and data function will be considered as non-members of this particular class. Okay, so I think this is clear now. Now let us main, since main does not belong to any class, so it's a non-member function. Let us create the object of a base class. Okay, say O1, and let us try to access the different parts of this class. Now I say O1 dot BA public part, okay, equal to 10. Okay, now let me compile. There is no error, I think. Yes, because we can access a non-member function can only access the public part of a class, but it has to access it either through the object or through the pointer. The same rules will apply to the object pointers that apply to the objects, but with the object pointers you will be accessing the members with the arrow operator, and with the object you will be accessing the members of a particular class with its dot operator. Okay, now I can say O1 dot B function pri. Okay, I'm calling it, sorry, I can call public first, B, and if you see there won't be any errors again. There are no errors, it's a success. So a non-member function main can access the public part of a class. Now let us try to access the private and protected part of the class. You will see there will be errors, and let me copy this and then change the name. Instead of public, I will call this now as private, and I'll call the private function. Okay, and I will access the protected part, and I will access the protected function. Okay, Now you'll see there will be 4 access violations in this case, because the non-member function main is trying to access the private and protected part of the class. Let us compile and see the access violations. Here we have b pri is not accessible, base b pri, base class is f pri is also not accessible, and pro is not also accessible, and f pro is not again a function f pro, b function pro is not accessible. So these are not accessible parts of the class. So for this is a general rule that only public part of a class can be accessed. So what is the entry point of a class? The entry point for a particular class is a public part, okay, that is we can only access the public members, and we can access only the public function, that is we can call only public function. So I will put this into the comment, and this rule you should remember, that any non-member function cannot access the private and protected part of a class, that is they cannot access it, okay. Now any non-member function will access the public part through the object, that is the local object, or through the global object, or through the parameter, okay. Now main is accessing through the local object, that is O1, which has been declared or instantiated within the main. I can have a global object, say base of say GL. Same rules will apply to this also, okay. That is you can only access the what you call through global object, you can only access the public part, and who will access? Of course the main or any non-member function that will access the global variable, that is the global object, can only access the public part. It cannot access the private and protected part. You can see here, suppose I'll try to access the private part of GL object, you'll see there will be error, okay, there is error, as I told you it is not accessible. And again if I say public part of GL, it is accessible, okay. So it is not accessible. Let me change it back into comments, okay. Now again I am trying to access the public part, okay, through the global object, it is accessible. So whether it's a global object or local object, same rules will apply, that is the public part of a global object can be accessed. Public part means both data and member functions can be accessed. Accessing the data members means using them in the assignment statements, inputting them from any input device like keyboard, or displaying their contents on the screen. This is equivalent to accessing a memory. Actually I have discussed this in detail in the previous sections, because all the data members are basically variables, and these variables can store values and they are memory locations, okay. Now this was about the global object, and this was about the local object. Local objects are those objects which are created or instantiated within a function, and global objects are those objects which are instantiated not inside any function, inside any body of any function. They are global, they can be accessed anywhere. Same is the true if we pass a parameter to any function as an object. Say suppose I will pass the object as base say O1, okay. Now I am passing the parameter to the x as O1, and x is again a non-member function. So the same rules will apply. Let us try to, because I have named the object, I can copy the same statement, but this O1 is different from the O1 of the main, okay. This is the parameter, okay, O1. Now I am trying to access the public part. Let us see, there won't be any errors. Now the moment I uncomment the private part of O1, now O1 is passed as a parameter, you see there will be access violations, okay. Yes, there are access. We cannot access the private and protected part of a parameter, that is a formal parameter, okay, because formal parameter is again equal to a local object. You should remember it. This is actually a declarative statement, okay. If you understand it in a broader sense, this is actually a declarative statement, but with the with the extra functionality that it can receive the data from the calling function, okay. So O1 is a parameter. Now I have showed you three cases, that is whether you access a local object, or whether you access a global object, or whether you access a object as a parameter. The same rules will apply, that is we can access only the public part of a class, that is a particular non-member function. Say in this case x can access only a public part, or a main, it can access only a public part, even if it is a member function of some other class, and if it receives the object of type what we call base, it can access only public part. The only way out, we have discussed it in friends function. I'm not going to discuss that here. So this is the general rule, you should remember it, okay, that a particular non-member function can only access the public part of a particular class, okay, whether it is through the object, or whether it is through the object pointer, or whether it is through the reference variable. Okay, three cases are possible. You are accessing either through the object, or you are accessing through the object pointer, okay, where you will be using the arrow operator, or if you are creating a reference variable for a particular object, again only you can access the public part. You should remember these are the three forms of access of a memory. That is, one, you can access with the name of an object, or you can access the object with a pointer, and that pointer should contain the address of that object, or you can access the object with a reference variable, that is you create a second name of the object. We have already discussed reference variables, okay. Now this is a rule that only public part is accessible in the non-member functions, but for member functions of a particular class, no such restriction exists, okay. Now you should keep this rule in the mind. That is the rule for the access specifiers, okay. Now let me create another class called as a derived class, okay. I'll be using same structure there also, but I'll change some nomenclature there, okay. Okay, I'll call this class as a derived class, not as a base class. Now I have two classes and a base class, okay. Now if I compile again, if you see, there is no error, okay. So I can have the base class and I have a derived class here, okay. In the base class I have got certain members, and in the derived class I have got certain members in the public private, but I'll change this nomenclature. I will call it as DA of pub, okay, and I'll call it as D function pub. Then I have to change this also, D, so that you can remember that this belongs to a derived class, okay. Okay, the inheritance, we have simply named the class as a derived class. We have not yet inherited the base class, okay. By naming the class as a derived class does not mean that inheritance has taken place, okay. I'll call this as again D D D, okay, D D so I, okay, D D. Now derived class itself can access all its member functions can access all the what you call other member functions, whether they are private or protected, as well as data members. So the same rules apply to every class, that there are no restrictions of access so far as the class's own members and function members and data members are concerned. That is, any function member can call any other function member. Now this is our derived class, and this is our base class, and the nomenclature which I have used is for base data members I have named prefixed them with B, and for and their function members I have prefixed them with B. For derived I have used the prefix D, okay. Now since there was no access violation in the derived class also, so derived class function, say D fun pub can access any member, okay. Same is true of D fun pro, and same is true of dfun pri. Okay, now if I create an object of this base class, sorry, derived class in the main, again the same rule is there, that non-member function can only access the public part. The moment they try to access the derived part, sorry, protected and private part, there will be an error. Okay, I can show you that also. Let us create an object of the derived class first. We have not yet inherited, because this will make you understand. So derived o2. Okay, now let me compile. There is no error. Okay, now I have a object with o2, name as o2. I can copy these statements as well. Now I can say o2, o2 and o2, o2. Now o2 is the object of derived class. Okay, and o1 is the object of the base class. Okay, now instead of b I have to use d here, because the member is not b from, then d. Now d, now d, now d and d. Since private and protected members I have commented their access, I have committed their functions and data members. Let us see whether we can access the public part first. Okay, this is the public part. Okay, the public part is o2.tapub and o2. Let us see if there is a violation. There is no violation. A non-member function main can access this rule, same rule, public part. But the moment I try to access the main tries to access the private and protected part, you will see there will be access violations and we'll get 4 errors again. So the same rule, that is the same rule, that function cannot be accessed and these members cannot be accessed, that is data members and protected data members and private data members cannot be accessed in the derived class as well. Okay, so this is access specifier so far as access specifiers of the two classes are concerned. Now let us move into inheritance. Okay, now I want that the features of the base class, what are the features? That is, its data members and function members should be inherited by the derived class. By that I mean that they should become the members of the derived class. How do we go for inheritance? We first give a semicolon, then we give the visibility mode, or we give the mode of the inheritance. Let it be public. Okay, public. Okay, and we say base. Now by using this statement after the class, what about definition that we normally used to have, we have added this statement, that is, we have added a colon and we have added the visibility mode and the class from which the derivation is taking place. Now the derived class is inheriting the members of base class. As I told you, the important rule here is that the private members of the base class won't be inherited. This is the first rule, that private members will not be inherited. What are the private members of the base class? They are ba pri and bfun pri. Okay, how do we know whether they are inherited or not, and what is inherited and what is not inherited? Okay, let us first see. Now if dfunpub, that is a member of this class, and which it can be accessed by any member. Now let us suppose that dfun, that is bfunpub, that is the base class's function pub. Since it's a rule, once we inherit, it should become the member of the derived class. Okay, once it's a member of a derived class, it is equivalent to the, saying that the definition of that function is present within the derived class. Now in public, as I told you, private members are not inherited, so they cannot be accessed. Let us try to access the base classes f fun pri. Okay, see whether we can access it or not. Since it's a member of a base class, let us see whether we can access it or not. We cannot access. Why? It's not accessible. So the private part is not accessible now of the base class. Okay, now let me try to access b a, that's base class is a pri equal to 10. Let us see what is the problem here again. It cannot be accessed. Accessing means that it has not been inherited. Let us try to see whether this function which belongs, that is dfun pub, can access the other things of a base class. Let me try to access bfun pub. I am accessing this function within the derived class function. Let us see if there is an access violation. There is no violation. So that means, how could I access a function of one class in the another class? This was not possible if I would not have written the what you call the statement for the inheritance. Since I have written the statement for the inheritance, what was the statement? That the base class has been inherited. That is why I could access the public function, that is I could call this function. Otherwise, normally if it's not there, let me put this into comments and see whether I can access after this. So there's an error. bfun pub should have a prototype, okay, because it thinks that it is a member of the base class, sorry, derived class, and it should have a prototype. You cannot do it. The moment I put the what you call inheritance statement, that is I inherit the base class publicly, you see now there is not any error. That means this function has become the member of, and there is no error. Okay, so I can access the public part of the base class in the derived class. Okay, now let me try to access another thing, that is ba pub equal to 10. Okay, or see, let me compile, so I can access again. So there is no error. What does that mean? That means that public part of the base class is accessible in the derived class. In other words, it has been inherited in the derived class. Okay, now let us try to access the protected part, bfun pro. I am calling the function which is the protected member of the base class. Again, if you see, let me will compile, and there is no error. Okay, again, that means I can call it. I can call the protected function of the base class in the derived class, because it has now become the member of the derived class. Even though the transfer of the code, that is from the base class to the derived class, cannot be seen with the naked eye, but in the background it has taken place. The data members and the function members of the base class, which are public and protected, have become the members of the derived class. That is why I am able to access and call them. Now let me try to access the protected data member a pro. You will see again this access can be done. Whether I can use a input output statements also, see in and see out for the data members. They'll work for the base class members, even though they are not the part of the derived class. But this has become possible because of the inheritance. Now let us see. Now this statement has also not led to the error. So in the derived class, if you inherit the base class publicly, you can access its public part and protected part because it has been inherited. Okay, the private part has not been inherited. Again, the same access can be performed in, now this was the public function of the derived class. We can do the same access in the protected function of the what we call derived class, that we can access all the public and protected members of the base class but not the private members. Okay, you can see that also. See here, if I compile, again there won't be any errors. Okay, so you can access in any function, whether it is a public function or private function or protected function of a derived class. You can access the public and protected members of the base class in them. Okay, let us place here also. Now this is a what you call private function of the derived class. Now let us try to access the base class members here, that is the public and protected members. You will see there won't be any errors. Let me compile. There won't be any errors because these have become the members of the derived class, that is the public and the protected members have become the members of the derived class. The members of the base class, only protected and public members are inherited. Okay, private members are not inherited. Okay, you have seen what is the proof for that, because we could not access them. Because we could not access them means that they have not been inherited. But since we could call the public functions or protected functions and we could access the public data and protected data of the base class, that means they have been inherited. Now let us see one more thing. Now in the main, let me try to access with O1 I will try to access the data member of the base class which has been inherited, that is BA pub, because public data members have been inherited by the derived class and protected members have been also inherited. But the rule is again the same. The non-member function can only access the public part of the any class. Now what is the public part of the derived class? This is the important question. The public part of the derived class is now its own public part and the inherited public part of the base class. Okay, and its protected part is now its own protected part, that is own function and data members, plus the protected part of the base class which it has inherited, and its private part is same as before, that is it is not extended because the private members of the base class are not inherited in any mode of inheritance. There are three modes of inheritance. This is what we call as a mode of inheritance or visibility mode, that is the public mode. Now this mode of inheritance is here is public. Now we can have three modes of inheritance. So this is actually the public mode of inheritance, and in public mode of inheritance what happens, the public what you call members of the base class become the public members of the derived class. Okay, and the private protected members of the base class become the protected members of the derived class. This is in public mode, and this is what happens to the public members in the derived class. They become public members and they become protected members. Okay, Okay, this is the public mode of inheritance. Now if the public members of the base class have been inherited in the derived class, that we have seen because the member functions could access them, but let us now check whether the non-member functions can access through the object, okay, of the what you called, sorry, we have to use the object of the derived class, not the public, okay. Because this is the one is the object of the sorry, one is the object of, I think, base class, we have to use O2. Okay, now O2, I will use O2 dot, I will not use DA pub, I will use BA pub equal to 90. Since BA pub before inheritance is not a member of O2, but after inheritance it has become the member of O2, and that too it has become the public member of O2. Let us see, we can access it. Yes, we can access it. This is a clear-cut indication that the public members of the base class have become the public members of the derived class in public mode of inheritance. Okay, now let us see again what happens after this. Let us see O2 dot, we can say pay fun public. So I am calling the public function of the base class through the object of the derived class. Before inheritance it was not possible because it was not the member of the derived class. Now after inheritance it has become the member of the what you call derived class, and if you see, it is accessible, no error is reported. So this is actually, now here I am accessing public member of base in derived class, and here I am accessing this is actually public data member because it is inherited, and in public mode of inheritance it has become the public member. Now public data member, sorry, public function member, member of base. Accessed through derived object. Okay. And same is true here, that the function member so any non-member function can now access the public members of the base class through the derived class object or its pointer or its reference, because the base class has been inherited. That is, the through the objects of the derived class. Now base class public members can be accessed, but this is when the mode of inheritance is public. What is the effect of the mode of the inheritance on the inheritance of the data and function members? That is, for public mode of inheritance we have seen in derived class what happens. in derived class what happens? In public mode of inheritance in the derived class what happens is like this. Okay, now I can put it in comments, and I can now inherit, show the second mode of inheritance, that is I will now privately inherit the base class. Now you see the effect. In the private mode of inheritance what happens is, this is the public mode. In the private mode what happens, in the derived class, in private mode what happens, the public members, in I told you, in any mode of inheritance the private members of the base class are not inherited. This is a rule, important. This will solve your 50% problem if you remember this, that the private members of the base class are not inherited. Okay, now since the private members are not inherited, we need not to discuss the inheritance. Okay, but since public and protected are inherited, but the way they are inherited, this will be determined by the mode of inheritance. That is, once they are inherited by the derived class, what will become their new access specifiers? This is the change. Since in the public mode of inheritance, the access specifiers of the data and the function members will not change. They will be inherited as they are. But in private mode of inheritance, what will happen? The public members, they will become the private members, and the protected members, they will also become the private members of a derived class. So in private mode of inheritance, the public and protected property that has been inherited from the base class will become the private property of the derived class. That is, their access specifiers will change to private. Okay, what is the proof for that? Now, in the first case, when we inherited through the public mode, the public property of the base class became the public property of a derived class. What was the proof for that? The proof for that is here, because we could access the public data member and the public function member of the base class through the derived object in the derived object, through the derived object, using a dot specifier in a non-member function. This was a proof because it's a public property, because only public property can be accessed. Now if you see, once I compile it, it will lead to errors. What are the errors? That these two things, that is base BA pub is not accessible and base B fun pub is not accessible. Why it has happened? Because here you have inherited through the private mode of inheritance, because I have changed the mode of inheritance to private. And once we inherit base class in a private mode, what happens? Its public members become the private members of the derived class, and its protected members become the private members of the derived class. But in the derived class, we can access them, no problem, because they are like its own members now. But with the object, there is always a rule. With the object, or with the object pointer, or with the object reference, you can only access what we call as the public property of a class. Since the public property of the base class has now become the private property of the derived class, so it cannot be accessed through the object or through object pointer or through a reference variable in any non-member function. This is the rule. So this is the difference between the private mode and the public mode of inheritance. Okay. Now again we go to the third mode of inheritance, that is we now go into the protected mode of inheritance. Protected base. Now, as I told you, the mode of inheritance is not like access specifier. It specifies what happens with the protected and the public members of the base class, how their access specifiers are going to change in the derived class. You remember this. There is only one mode of inheritance that does not change the access specifiers of the base class, that is the public mode of inheritance. In public mode of inheritance, the public and the protected members are inherited and they remain as public and protected members in the derived class. In private mode of inheritance, public and protected members become the private members of the derived class. In protected mode of inheritance, the public and the private, that is in protected mode, the public and the private members that are inherited become the protected members of the derived class. Okay, I hope this is clear now. Since they become the protected members, again in the non-member function they cannot be accessed. That is, the members of the base class cannot be accessed in the non-member function through the object of the derived class, okay, or through its reference or through its pointer. This is what actually makes three different modes of inheritance. That is what happens with the access specifiers of the data and function members of the base class. As I told you, you should remember private members of the base class are not inherited. How did we prove that? Because we could not even access them in the member functions of the derived class, but we could access the protected and the public members of the base class in the member functions of the derived class. Okay, in any mode of inheritance they can be accessed. Okay, but you cannot access the private members of the base class even in the member functions of the derived class. This is a clear-cut indication that the private members are not inherited. Okay, now let me show one more thing, that is let me create two constructors now. This was so far as the mode of inheritance is concerned. This is the explanation that I have given what happens with the protected and the public property that is inherited by the derived class. Okay, now if I compile here, I think there was an error, and yes, I told you in protected mode of inheritance also we cannot access. Okay, so we have to put now this into comments. Why? Because now the access mode has been put as private. Okay, now let us write down the constructors for the what you call base class and the derived class. Okay, now if you see here, I write a constructor in the public section of the base class. The name is base, so I'll say base. Okay, in the base. Now this is my constructor in the public section. Okay, I have to remove this here. Okay, then access all the member, I initialize all the members. I can initialize, write these statements here. Okay, I can initialize them to zeros. Okay, now this is the constructor of the base class. Okay, now I can write the constructor of a derived class also. Now I move to derived class. In the public section I have to write this constructor. Okay, Now what's the name of the class? I think it's derived, right? So I have named the constructor as derived, and because the name of the constructor is same as the name of the class. Okay, now I initialize its members. Now its members are not only the members of its class, but they are the public and the protected members of the base class are now also its members. So I can equally initialize them here. Okay, but actually we don't initialize them because for the base class we have their own constructor. So let us initialize only. We can do that also, but since it has its own constructor, let us see what happens here. Now I initialize its members to 0. Okay, let me compile now. So the two constructors have been created, one for the base and one for the derived. Okay, now I'm going to show one more thing. Okay, F7. We are first creating the base class. Now I'm executing the program. The base class is O1. Okay, the object name is O1. Now if you see, the base class constructor has been called. Okay, now my point of interest here is what happens once I create an object of the derived class. Since the members of the base class have been inherited, okay, what happens? What is the order of the constructors? Okay, now the derived class has inherited from the base class, so base class is hierarchically in an upward level than the derived class, since it's a parent class. Okay, let us see now which constructor is first called. Okay, now the constructor of the derived class has been called. Okay, but it has not finished the execution, but it has called the base class constructor. Okay, so the first constructor that will be executed will be the base class constructor. This is important, that is the order of construction. Now see, the three members have been initialized, and if you see now the derived class constructors, its statements are being executed. So order of the constructors is that the base class constructor always is executed before the derived class constructor. That is, the order of the construction is the class hierarchy. Okay, the order of the class hierarchy. The base class constructors will be always invoked and called and executed before the derived class constructors. This is one rule, the order of construction once we create a derived class object. Okay, so the order of the constructors is first the base class constructor is called and executed, then the derived class constructor is called and executed. Okay, now let us see the order of destructors. Okay, order of destructors now. Okay, so I am going to create a destructor now. This is one more point that I want to clarify here. Now suppose this is the destructor. I'll copy the constructor here. Constructor, I'll copy the, and I'll precede it with the title character, tilde character. Okay, this is the indication that it is a destructor. I will display a message here. Cout destructor of now base class. Okay, this is the destructor of base class. Okay, now I'll create a destructor for the derived class. Okay, destructor for the derived class. Okay, this is the constructor and I'll create a destructor. Okay, now I put a tilde character here. Okay, now I can input a message here. Cout derived class destructor. Okay, so we have created the two destructors, that is the base class destructor and the derived class destructor. Okay, now let me compile first. There's no error, so we have created the destructor for base class and derived class. We have seen the order of the construction for base class and derived class, and this is now basically we are discussing single inheritance. If you remember, I have already told that we are discussing the single inheritance in this example. Now let me put the base class statements. I will only create a derived class object. Okay, comments. Okay, let me put this into comments, then it will be okay. So let us execute. So first the constructor of the base is executed, then the constructor of the derived is executed. So you have seen the order of the construction. There is one more step. Now if you see, now which destructor has been executed first? The statement of that has come on the screen is derived class destructor. This statement first to be executed. This is the destructor that is executed first, that is the derived class. And if you see in case of the constructor, which constructor was executed first? It was the base class constructor. Okay, so the order of the destruction will be reverse to that of a construction. Now if you see, after that the base class destructor has been called. Okay, and it has been executed and main has terminated. And if you see, after that the statement that destructor of the base class has been executed. Okay, first the derived class destructor has executed, then the destructor of the base class has executed. I hope it is clear now. Okay, so we have the order of the destruction is reverse that of the constructor. Since we have a global object for the base class also, the second statement came because of that. Run the program. Okay, now you see, first time the derived class constructor is called, but actually the base class constructor will be executed first, then the derived class constructor is executed. Now for the destructors, the derived class destructor is executed first, and after that base class destructor is executed. So you will have two messages now. Okay, let us see. You have got two messages. First the derived class destructor is called, then the base class destructor is called. Okay, so you should remember the order of the construction and destruction. The order of the construction is that of the order of the class hierarchy, that the base class constructor is executed before the derived class constructor, but order of the destruction is reverse of the class hierarchy. The derived class destructor is executed before the base class destructor. Now this was all about the single inheritance. There is more we should know about the what we call constructors. Since I have already only created the default constructors here, we can have the parameterized constructors, and we can have multiple levels of inheritance. We'll be seeing different forms of the inheritance in the coming video. And one more important topic that is related to the inheritance, that is what we call as virtual functions. Okay, that we'll see in the coming lectures. Thank you for watching.